Merci. Bon, je vais présenter en anglais. Merci. So hello everyone. Today I would like to present to you one part of my PhD thesis, namely comparison of image content by multivalent gap matching under the supervision of Professor Jean-Yves Hamel and Nicolas Montmarché at University of Tours. I divide my talk into 5 main sessions as follows. So let's start with the context. In fact, in daily life, we usually deal with the numeric data, but besides that exists another kind of data, it's the graph structure, and it's a non-usual data. It's difficult to present in 1 or 2 dimensional. However, the graph structure has very powerful representation, and so it's applied in multiple application contexts. For example, in drug discoveries, the chemical compound is very similar to a graph structure, or in human action recognition, we can think the body skeleton is like a graph, where the nodes are the subparts of the body and the edges are their relation. Or in brain connectome comparison, where the brain region can be considered like the nodes, and the connection between brain region can be the edges. And when we have the gap structure, we can do the gap comparison problem or gap matching. It's either the similarity measure between 2 gaps to say how different 2 objects are under the form of the gap, and it's a non-negative value, but the magic probability is not obligatory respect. And in my thesis, I focus on one kind of gap matching. It's a multivalent gap matching. So it belongs to inexact gap matching. It allows you to do one-to-many or many-to-one correspondence. So it's more general than one-to-one gap matching in real life like this. However, it has higher complexity. And so why do I consider this kind of problem? In fact, in computer vision, we can deal with a lot of problems related to multivalent gap matching. For example, in image segmentation, you can have under segmentation or over segmentation. In this case, the one-to-many or many-to-one mapping will give you a better result after a post-processing process after the segmentation. Or in computer art design, here maybe some parts of the object will correspond with just one part of another object. Or in the video checking, you can have inclusion or occlusion. And or in symbol recognition, you might have very distorted symbols, deformed symbols. So in this case, multivalent gap matching can be useful. Here I just go quickly some literature review. So in this domain, the most popular technique is gap edit distance. I will present more detail later. And the popular solver is heuristic approach because of its high complexity. However, the computational time is still a problem. So from the literature review, and from the problem formulation in the previous work, we propose in this work try to improve the computational time and try to enhance the performance for the symbol recognition problem. So what's a gap edit distance? Gap edit distance is the dissimilarity measure defined by the minimal cost of the edit path. The edit path is the set of edit operations that allow you to transform one gap to another gap. And from the definition of the gap edit distance, I call J for shortly, we extend it. We formulate the multivalent gap matching problem and extend this gap edit distance with two additional operations, merging and splitting. with these two operations, it allows us to to consider merging and splitting one-to-many and many-to-one correspondence. And here I give one example of XZ. So, for example, I want to transform the gap G here into the gap H here, and they may exist a lot of edit paths that can transform G to H. Here I give one example with the edit path lambda, like here. So how is it? So first of all, in this edit path, it will consider, for example, the node A can match with all the other nodes in the gap H. So I can to match A with 3. In this case, it's called node substitution. And maybe they have the same attribute, the same color, for example. It will cost 0. And it is similar to do node substitution from C to E. And it will cost 0 as well, and then it will consider the S substitution between AC and 3E. And it repeats this step until the edit path is complete. It means it contains all the nodes and entries from both gaps, and at the end you can have the 0.22, like it is the dissimilarity measure between the two gaps according to the edit path lambda. And in addition, you based on this edit path, you also have the subpath mapping between the node and the entry of two gaps. So in my work, I propose to solve the XZ problem by the colony optimization, especially Maximian system, which is a variant of ACO. So I have the input with E2 compare graph, and then I build the cost matrix as a heuristic factor for this for M match, and then I build the construction gap as the solution space for the colony. The local shot is optional. It can help you to improve the solution quality, and at the end it will give you the best file edit path that contain the dissimilarity measure and the node correspondence. And here how the within an colony, each arm will start with an empty edit path. It will update the candidates based on the transition probability here, and then it will stop until the edit path is complete. So I will go more detail on the important factor. The first is the heuristic factor. So this is cost matrix. This cost matrix presents the goodness of the nodes of the pair of nodes from two gaps. And like in this matrix, and each block here presents one type of edit operation. For example, here it is node substitution, here it is node splitting, here is node deletion, node substitution, and so on. And for the construction gap, for the meta heuristic algorithm, for example, ASO, it's important to have some information to guide the answer for a good solution. So in this case, it is the pheromone factor, and this pheromone factor is laid on the construction gap here. This construction gap is undirected and complete. It presents on the possible possible edit path that the end can find for the problem, and at one time just one unique operation is applied for each node from both gaps. In this work, I try to reduce the computational time by applying the neighborhood strategy. So in fact, in the revealed work, after to look forward to look the next candidate to update the edit path, it will consider all the remaining candidate. But here I just consider the neighbor of the candidate previously selected. So in that way, I can reduce the search space, and it will reduce the computational time. However, you can lose the good candidate. It means that you can have lower solution quality. And here I present one experiment for the symbol recognition problem. So here I have a lot of symbols with various form, and this you can access to this data by this link. And then I ask the noise to rotate, to scale, or to deform the symbol. Here is one of the example of the deform symbol. You can see here it's a very distorted because maybe one line will be broken into several lines. And one important step for doing graph matching is doing gap representation. So here it's not a straight line corresponding to straight line in this symbol, and the edges are the 2D relation between lines. The node attribute are the relative length, and the edge attribute are the relative angle and relation types. So here is one example for the gap representation of the symbol on the left. So this gap contains both the numeric and the symbolic attribute. And then I analyze the region, the experimental regions, into aspect, quality analysis and quantity analysis. So for the first ones, I focus on the low-level matching. It means the subpath correspondence between the objects. So I give here one example of the symbol 032. So, and I compare with the one very famous method of for exact. It's the bipartite gap matching. So here is the original symbol, and on the right are the noisy symbol. So the same color indicate the same correspondence. So here we see, for example, between the original symbol and the noisy symbol here, level 10, the traditional methods bipartite gap matching just subset just to mask 1 to 5 here, and they delete another line. However, our methods subset to mask 1 with 5 and 9 here. So thanks to the splitting and merging operations. So in fact, with the HZ, it gives a more meaningful result in the real context compared with the traditional object. And so for the quantitative analysis, I apply it in the classification context. I want to classify 20 classes. However, the train test contains only the model, and the test set contains only the noisy symbol. And I use just one nearest neighbor. It means there is no training information in this classification, and I use the gap distance direct measure to classify. And here are some results. So we see that compared with the traditional jack, the improved method gives a higher accuracy, and compared with between the improved and the previous one, is the more time consuming, more time saving. And so in this work, I propose a strategy to improve the performance of the mass exact in the previous work, and better results are obtained for the symbol data set. Also, a better trade-off between the computational time and the solution quality. And in the future, I would like to apply the method for the human brain connectome comparison in this pilot. So here we want to know what is the difference between the organization of a brain of a patient like Alzheimer's, Parkinson, and the difference with the brain of a healthy people by consider the patterns, by consider the difference at low level, like between the region inside. And now here I'm at this step doing graph presentation to do the gap matching and analyzing the result. So thank you so much for your attention.
maybe I missed it, but you have valued edges, and when you change the value of an edge, it is the same cost for in the past. Whatever, if the value of the edges are very different or if they are very close, when you make the change of value, is it the same cost?
No, in fact, the cost is defined by the cost function, and the cost function depends on the data set that you use.
Okay.
Yes.
So you can take into account that the values are very different?
Yes. Also, you can design the cost function that consider the edge attribute and the north attribute, and the add attribute you can have multiple attributes as well as the north attribute.
But then it is very long to solve.
No, it normally it's it's not long because it's already defined function.
Okay.
Yeah.
Thank you.
Yes. Thank you.
What do you want to do? Do you want to at future work extract statistics out of it, or
this one?
some means, or
This one, in fact, is more about anatomic of the humans brain connectome. Connectome is a term to indicate the connection between the brain region inside. So what we would like to know is we will not consider the anatomic structure because it's already defined by the brain's atlas. What we want to know is more about the functional brain network because, for example, if you do a specific task between normal people and a patient, how about the difference when the region in the brain interact together, and
clustering, for instance, graph clustering, or
no, it's about graph comparison. Yes.
Because there is a small problem with the graph edit distance is that in terms of metric, the distance can exist, but there are no unique paths between graphs.
Yes.
There are infinitely many. Even, I mean, you will have infinitely many shortest paths between two graphs at this distance. So that will cause a serious problem.
You can have the minimal cost, but the edit path will not be unique because it's like a permutation between the nodes, between the order of the pair of the nodes in the edit path.
Yeah.
Yes.
Pendant toute la présentation, en fait, tu parlais pas de l'application du tout. Ou alors je l'ai manqué, peut-être, j'avoue que...
Je pense que plus petit, c'est le premier, c'est full symbol recognition.
Ouais. Ouais. Mais en fait, au fond, oui, moi je me demandais, mais pourquoi, à quoi ça sert en fait de regarder les différences entre symboles. Mais en fait, ce que tu veux, c'est au final, c'est comparer des... C'est pour ton application médicale, en fait. Il n'y a pas de...
Oui,
théorique, on va dire.
Yes, I understand. Because in fact, one of the problem with my problem is the lack of the data set. So I have just this one data set to be demonstrated that my approach is feasible, and then I will try to approach for the real applications. Yes. Yes.
Okay, merci.
Thank you so much.